for today?
I think Paul's in. Hey, Paul.
Good morning, good afternoon. How you
Hey,
doing?
Paul, thank you so much for being here. How are you today?
I'm great. Thanks for asking me to join.
That
How are you
is
guys doing?
awesome. Thank you, man, for joining us. Just to let everybody know, I think it's 3 times a week. Paul is hosting a live stream through through Instagram. Is that correct, Paul?
Yeah, Monday, Wednesday, Friday, 9 a.m. Pacific. We basically like talking shop, talk about Fusion, answering questions, and we bring a bunch of guests in as well to tell you about how they use it and share some tips and their unique workflows.
That is awesome. If you do have Instagram, go ahead and look up Autodesk Fusion 360. If I'm not mistaken, that is the name of the channel, and just join him. It's he has a you've grown quite a bit of following there, Paul. Since then, you got a
Right.
nice got a nice following going on there. You've been hosting it for like 3 weeks now, or a little more,
Just over a month actually.
for like a month. Yeah, he has a really nice following going on. Some great information. I saw some screenshots that you shared with us just the other day. So, today I invited Paul to join us today because we wanted to show methods in which in Eagle you could assign 3D models to your components, and we have 3 methods, and I'm going to review them right before we actually have Paul do the demonstration on Fusion 360. That way he could share his screen. So what we do is that we have this system called Manage Folder, which can be used in Eagle. It can be used in Fusion 360 electronic design editors as well. And there's several methods by which you could assign 3D models to your components. We have a package calculator. We have a repository of 3D models that you could assign as well, and you could upload a step file as well. Now, before I go there, I just want to let you know that every day of the week on the Fusion 360 YouTube channel, every day of the week, we are hosting different topics in regards to Fusion 360. Jorge and I are lucky enough that we are assigned to Wednesdays. So if you want to join us tomorrow I'm going to be doing a review of the entire electronic platform that exists in Fusion 360. So I'm going to show you how to access it, what is the electronic document, how to take advantage of it, creating your first schematic, your first board, generating your manufacturing files, DRC. We're going to go over all of that tomorrow at 2 p.m. Eastern time. So I hope you really have some time to join Jorge and I tomorrow afternoon. Now, let's take a look at Eagle really quick. So I got Eagle here launched up. This is the Eagle control panel, as you already know. Okay. And if I expand the library tree, you'll see that you have your access to all these libraries that we have. Some of them are actually my local library, some are managed library. In essence, a managed library, basically what it means is that it's a library that is on the cloud, but it's synchronized with my local copy of that library. And it expands the capability of that library to assign 3D models to it. The primary advantage of is I can assign 3D models. Now, when I work in Eagle and I push to Fusion, I actually see the component in all its glory in 3D model. In addition to that, I could access those libraries remotely. So if I have to move onto another computer, I could log in using my Autodesk account into Eagle, and I could still access those libraries because they're managed and they have remote access, and I could go ahead and download them and put them in use to continue working on a design that I most probably already have. Now, I have a library already here open. It's a simple library. So when I have a managed library, there's several indications letting you know exactly how that managed library works. So let's take a look at that. First of all, you will always see a version number. As you could see, it says version 7. That is just letting me know that this is a managed library. And I've been pushing and kind of pushes and pulls every time you synchronize. So I'm at version 7 of that. So this is one indication just to let you know that we have version. And down here, I don't know if you could see it, but all the way down on the corner, there's a little file cabinet symbol. Maybe I should resize this just a little bit, that way you can see it. So let me just resize this just a tad. That way you could take a look at what's going on the bottom right corner. So right there, it's just if that ever turns a different color, it means that you need to synchronize. Okay. If this ever turns into a blue, it's mainly blue. It means that the file is not synchronized at that moment. So let me show if I could do that. We save the file. And as soon as I save the file, you get all sorts of notifications. It's letting me know, look, there's some local changes. I need to create a new version, which means I need to synchronize. Right here down below, the file folder turned blue, and it's letting me know that I need to synchronize. And up here, it says version 7 plus edits. Therefore, it wants me to synchronize as well. So let me just go ahead, and the way you synchronize the library is that you click on library and select create new version. What it does is that it actually uploads the library to our cloud, which is library.io, and it downloads it back to Eagle, is what it's going on. And that's how the synchronization, you'll notice that now we have version 8 going on here, version 8, and our file folder has gone back to blue. I mean, sorry, went from black to blue, from blue to black. Now, assigning 3D models to our components actually has 3 methods right now that we have. I could right click the component and select the option here. It says edit. Okay. When I select the edit, it actually brings me to something what we call the package editor. At this moment, I don't have any 3D model assigned to this at all. I could either add one from our repository of 3D models. As you could see here, we have a large repository. This is my repository. If I want to see the one that we have available to our public, we select here on public, and we have a nice large repository of components. If you have somewhat of an indication of the name of the component that you're looking for, the 3D model, you could actually use the search option, this search option that we have here as well. Now, in addition to that, we could generate a 3D model. We could generate the 3D model using what we call our IPC compliant package calculator. The calculator includes multiple templates. The majority are IPC compliant, but not necessarily all IPC compliant. Okay. We've been able to create some templates for some non IPC actual components. I could select the component I'm interested in. I could type in the values based on the specification sheet from the manufacturer, and that will create a 3D model for us. But in this case, we're going to be going over an example in which none of this actually works. I actually have to upload a step file. I actually have to upload a step file. And the step file, it's quite possible that I got it maybe from a manufacturer, either a distributor like DigiKey, Mouser, or I went to Snap EDA, or you go to Semaxis. There's multiple resources that you could actually get 3D models. You let me know, Jorge, if I'm missing any of them. But you could go out there. Even the manufacturer itself might have the 3D models, but there'll be instances. I'll be honest with you. There will be instances that you will not find that 3D model. Okay, and you will have to build it. How do I assign a step model to our components in Eagle? I click here where it says upload, and I go ahead and I will select the step file that I actually want to use. In this case, I'm using the ion chamber. This is a smoke sensor, and I'll click on open. And when I bring in that step file, I wish it always came in a line. It would be ideal, but it's quite often that it does not come aligned. So I actually might have to do a little bit of alignment to actually line up all the holes with it as well with it. Now, this browser that we're using, this package editor that we're using, it's actually on the cloud. It's working directly through IO, and it's working through Eagle. That way I could do this model. I just wanted to cover this section before we have Paul create the step file for a model that we've challenged him with. That way you could see how the mapping actually works in Eagle before he goes over the Fusion and actually build a part for us. So, okay, it's loading the file. There it is. And I'll just use the alignment tools that we have here. So just go ahead and line this up really quick. Take a look at it from the bottom. The holes are not lining up, so you just go ahead and move it around. And there it is. It's perfectly lined up. Oops, I moved it by mistake. And it looks good. Okay. Now this is actually one example in which I couldn't find this step file. Somebody from the Fusion team actually had made it and let me use it as well. So today, what we're going to be doing is that if you have an electronic component that you want to use on your design, and you just don't find a 3D model for it, Paul's going to show us how to use Fusion 360. What are the techniques in Fusion 360 to actually build those electronic components that you actually need to use to actually map out your footprints in Eagle as well. So I'm going to go ahead and stop sharing, Paul. That way you could take over. Is that good?
Sounds good. Apologies, I forgot to unmute myself there.
Thank you so much, Paul. And thanks for being here. Hey, Paul, before you actually begin the demo, could you just tell us a little bit about you and what you do and what's your role at Autodesk and in Fusion 360?
Absolutely. So I am one of our Fusion 360 evangelists, and now I do a lot of our content marketing strategy, but my roots are very firmly in industrial design. So I spend a big portion of my time working with users, helping them out, getting started with Fusion, as well as helping them develop and build their products. So, I get to use Fusion quite a lot and get to work with some pretty amazing people, and quite lucky to have this really cool job, actually. All right. So with that said,
Sorry
let's.
about that. Thank you, Paul. I totally
Oh,
forgot
yeah,
I had muted myself. Go ahead, please. Go.
all good. So with that said, let's jump in. Jorge sent me over this file. Let me just show you what we're working with here. So this is the spec sheet for the jack that I'm going to model today. So this is all the data we have. This would be the standard kind of spec sheet that's sent out. It's very, very easy to model a part based on this. So I only got this a few hours ago, and I was just having a little play and practicing with this here. So let's start a new file and build this guy from the ground up.
You know
So
we're not going to make it easy to you, Paul. You know better than that, right? Yeah. Okay, let's just see how good he really is. Let's give this to him right before the webinar. Go.
Oh man, well, I like a challenge. So before we get started with the actual modeling, one of the first things that I like to do is just make sure that I know what it is that I'm making. So obviously for everyone out there, you'd be pretty familiar with the components, but when I talk about what we're making, what I really mean is how do we break down how we're going to model this? So this one's pretty straightforward. We have one component here. We've got some washers. And then the main unit, which is where the actual parts will mount to the board. So that's where the jacks are. So when it comes to modeling the thing, I'm going to do the same thing and break it down into 3 different pieces that I'll then put together. That might sound like more work than it actually is, but I promise you it's crazy fast. So I've jotted down dimensions, so I won't be jumping back and forth from the PDF to what we're doing today. So with that in mind, let's jump right into it. So the first thing that I'm going to do is go over here to create sketch. And it's going to ask me which plane it is that I want to work on. And I'm going to pick this ground plane. From here, I can hit R on the keyboard as the keyboard shortcut, or just click on my 2-point rectangle here. And this is what I'm going to use to draw the base of the main component. Now, before I actually draw it, what I'd like to highlight to you is that you actually have 3 different ways of drawing rectangles. So you have the 2-point rectangle, which is what I'm going to use today. You have a 3-point rectangle, which enables you to select your width and height independently instead of doing them simultaneously. And then lastly, you have a center point rectangle. So let's say the center point of your rectangle or square is the most important element. That would be where you would begin the part. So I'm going to stick with our 2-point rectangle here, and I'm just going to pull this up. So our width, or our height rather, is 20.61 millimeters. And it's 18.2 millimeters in the other direction. Now, just very quickly to jump back to that file, you'll see that the units are provided in both millimeters and in inches. You may have gleaned from my accent that I'm not American. So I do like the metric system. I like simple numbers, and counting to 10 is easy. So that's generally how I stick to things. So let's just keep rolling. So I've got the little base piece here. All I'm going to do is hit finish sketch. Now at this stage, you'll note that there's a little icon in my timeline here, which is the sketch itself. And my browser now has a new folder with it called sketches. And in there is sketch 1. So sketch 1 is just what I've created here, and these will be added numerically. So as I go along, you'll see sketch 2, sketch 3, sketch 4, etc. But of course, you can just double click and rename it like that. So let's just call this base unit. Next up is the actual height of the thing. So we'll go to create again and use extrude. So with extrude, you can see the plane was selected already. So this has popped up. I also have a dialog box over here asking me for some input. So you can tell it where it is that you're starting from. Maybe you want to do a one-sided extrusion, two-sided, meaning that you're using your plane as your profile as an origin point. And then lastly, you have symmetrical. In our case, we're just going to stick with one-sided, but I always like to highlight that these options are there. Also, if you happen to need to create something with a draft angle on it, you can actually do it as part of this operation with a taper. We don't need to worry about that for today, so let's just put in our distance here, which is 8.14 millimeters. So that's our first piece. Next, we've got the actual 1/4" jack where it needs to connect. So what I'm going to do is just click on this face here, and I'll pull this out because I want to create this part a little further away from the piece so that I can bring it all together afterwards. Now, standard 1/4" jack usually has some kind of hexagonal port on it. This helps us screw them into place as well as be a quick visual identifier. So we're going to create another sketch here. And one of the things that you'll note, just if I go back to our profile here, you can see that there's a big washer that is pretty much hits the center point of our rectangle and goes down to the bottom height. But no unit of measurement is actually provided. So it doesn't tell you what the exact diameter of this piece is. That's not a big deal. All we have to do is when we use our center diameter circle, you see that we can actually kind of snap there, but that's not a true snap. So what I want to do is actually project that edge in. So what I'm going to do is go to create, project, and then I can click on this surface, hit OK, and you'll see a purple line. Now I can use that as reference. That line is actually relative to the sketch itself. So you can see as I've rotated there, the line isn't touching the actual part, but it's in line with where my sketch plane is. So you can see the grid is offset from the surface because that's where that construction plane is that I told it that I want to do the sketch from. So I'm just going to hit this little look at button, which will snap me back to my 2D view. And then I can hover over my midpoint. You'll see that little triangle there denotes that I'm at the midpoint. And if I just pull this down, I can get to that position there. You can see it snaps to it. So it's 16.14. That's the first piece of my 1/4" jack. The next piece is going to be the actual hexagonal element. So under create, you'll see we've got polygon, and there are a few options. You've got circumscribed, inscribed, and edge polygon. Circumscribed basically means that the point from the center to one of the edges is the unit that you're defining as your radius. Inscribed means that the outer limits of your polygon are what you're defining. In our case, we're going to use circumscribed, and we'll just click there and start to pull it out. And we know that it's 11 millimeters across, but if I put 11 in, I'm actually defining the diameter. So Fusion enables you actually to do maths as you go along. So all I have to type is over 2 and save myself the kind of 0.1 seconds that it would have taken me to figure out that that's 5.5. But I like to highlight that so people know that you can actually start to write quite complicated algebraic functions right into your unit dimensions if you need to do so. So with that done, I'm going to go ahead and hit finish sketch on that piece. Now you might have noticed that I haven't actually added the hole for the jack, but that's not a big deal. The reason I'm not doing that right now is, again, going back to our sketch, you can see we have a hole here, but we also have these 3 washers which will have that same hole in them. So I don't want to model that right now. I don't want to put the hole in right now. I'm going to do that at the end, so I don't have to do it multiple times. I can just do it all at once. So again, just going to use my extrude tool here. And we know that the total width of this is 3.17 overall. So I'm just going to type 3.17 over 2. And then you'll see that the sketch disappeared. Now that's the default behavior in Fusion 360. What it does is, as you've created a sketch and you create some 3D geometry from that, so using an extrusion or maybe a loft or whatever it is, when you complete that function, it will automatically hide the sketch as a way of kind of neatening up the 3D space. But you can see I have my browser open here, and all I have to do is reactivate that. If you don't like that, if you prefer it not to do that, you can actually go into the preferences in Fusion 360 and switch that option off. I'm going to leave it on because for the most part, I find that it's more useful for me to have that switch, have it automatically hide those for me. So now I need to go 3.174 in the other direction. So to do that, I'm just going to put a negative in there, and it's 3.174. over, excuse me, over 2. And you'll see that it's extruded in the other direction. Now, before I hit OK, one of the things I want to just highlight as well, you can see that it's actually fixed the maths for me. So I just typed negative 3.14 over 2. And if you know your algebra or you know your maths, you know that that function isn't actually going to work. What, strictly speaking, what I've written here is dividing the decimal over 2, not the whole thing. So you see this has been put into brackets. It's also been multiplied by 1 just to ensure that all the maths is correct. The other element that's worth highlighting here is that the operation has automatically detected that I'm touching another 3-dimensional surface. So it's wondering if I want it by its default operation is saying, hey, I see you're touching another surface. Presumably you want to join those 2 pieces together to create one geometry. And that's exactly what that's doing. That's what I want it to do. So I'm going to leave it be and hit OK. So now if I open up my bodies folder, you'll notice I've got body 1 and body 2. Body 1 being the main base here, and body 2 being the first pieces of our jack that we've created. Next up is the washers. So for the washers, just to make life a little easier, I'm going to just create another sketch and do it on that plane. But, oh no, my jack from earlier on is in the way. I've got a couple options here. Of course, I can just hide that part and then hide that sketch independently, but sometimes it can be a lot of work. Instead, you have this option here that's called slice in the sketch panel. And if I click on that, you'll see that it's automatically hidden the 3D geometry for me because that's in front of where I've defined my sketch plane. So if I zoom out, you'll see that my sketch plane is touching that surface. And if I switch off slice, slice is removing everything that's in front of the sketch plane that would obfuscate my view of what I'm working on. Again, it's one of those tools that I really like to highlight because it's one of those quality of life things when you're working with any 3D data that just makes life a lot easier. So what I'm going to do here is just if I hover over my edge, you'll notice that it's already picked up the coincident. Now, what I'm going to do is just ensure that I'm looking at this correctly. Now, the reason for that is because I actually selected the face. Now, because I selected the face, it automatically detected the edges of that face and allows me to use them as references as opposed to earlier on when I was using project. So from here, I hover over my midpoint, do the same thing, just pull it down, click once, excuse me, and I can finish my sketch. Now at this stage, I'm going to go ahead and extrude that one as well. So just pick the 2 surfaces there. I can deselect that one that I clicked on incorrectly. The unit there, for anyone wondering, is 1.2 millimeters. So again, just type 1.2. And you'll notice, again, because my piece is touching up against that face, it says operation, do you want to join? In this case, I don't because they're separate parts. So I'm just going to change that to new body. Now I need 2 more of them and I could just, copy paste it or do it again, but I like to use this rectangular pattern function here, which is up here in the toolbar. The pattern type I'm going to use is bodies, and I'm just going to tell it that's the thing I want to repeat. Then I have to define the direction that I'm repeating it in. So I'm just going to use the edge of my part here. It's by default going to create 3 in total. So as I move that out, you'll see there are 2 ghosted versions of the same thing. And I can go ahead and hit enter on the keyboard, and I have my 3 repetitions. Now I need to put that hole in place, but before I put the hole, I've got to hollow this out. To go back to our part again, you can see what's going on here. If a 1/4-inch jack is going in there, of course, I can't have a solid volume, otherwise it's just going to crash. There's nothing for it to touch. So the first thing I'm going to do before I do my holes is under modify, we have a function called shell. Now, what shell does is it basically just shells out a geometry. It does exactly what it says on the tin. So I can click on this top surface and define a wall thickness. In our case, it's 1 millimeter. And what you'll see is that it's scooped all of the volume out, excluding that 1 millimeter wall thickness. You can also change the definitions. Maybe you define your internal volume and now you need to put a wall around it. So you can go outside and then do the same thing, and it'll basically remove what you had before and build a 1 millimeter wall that encapsulates that volume you had. So let's leave that at 1, go ahead and hit OK. And now I can show you how that hole function works. So I'm gonna go to hole up here, click on my surface, and you'll see that it just drops a hole in place. Now, what I'm gonna do is grab that little crosshair and you'll see that dot. Now, if I let go, that dot disappears. If I click again, that dot is there. That dot is Fusion recognizing where the center point of a geometry is, where your hole has been placed. So as soon as I get close to that, you'll see it snaps. Once it's snapped in place, you'll also notice that it has a point on it. This is because it's simulating a drill bit. Of course, you can change that, but for the sake of today's exercise, that doesn't matter. The other thing I want to highlight to you is that you can also add a counterbore or a countersink as part of that same operation in case you need those voids for the kind of screws you might be using. In our case, again, doesn't really matter, but would like to let you know it exists. Now, we know that we're producing a headphone jack for a 1/4-inch jack. Now, I could do the maths and convert that for myself if I wanted to, but Fusion's pretty flexible in that respect. So I can just type 0.25 in, and it's going to put my 1/4-inch hole in place. The next thing I need to do, of course, is just extend that through to make sure we punch the whole way through our object. With that done, let's start to snap a few of these things together. So I'm going to use the move function here by just hitting M on the keyboard. And I'm going to use our point to point. So point to point enables me to reference centers of holes like I'm doing here. As I hover over that edge, you can see a little crosshair has appeared. And if I click there, and then I click on my next one, excuse me, and got to define a geometry first. So that's the thing I want to move. Let's just, did that in the wrong order, my apologies. So that's the thing I want to move. That's the origin point, and that's where it's going. Another way to do that, just to show you with the move function, if I'm stuck in this, if I'm just using the regular move and I tell it this is what I'm moving, now it's highlighted the origin point is at the same place where the other one was. If I grab that arrow and move it around and then just click on this surface, it's going to snap to it because it knows that I've already told it I'm moving in this axis and I want to move this where my origin of my move operation is to coincident with whatever surface I've clicked on. So move that in place, and then let's just repeat that one more time. And I can do the same thing I just did there, grab that, and then just click once, snap, all those pieces are in place. Now looking at our sketch, we've only got a few things left. We've got these little ridges here, which is to prevent the jack from wiggling, and our connectors. So to do the actual jack, these elements, which are to prevent the jack from wiggling, I could arguably just repeat these in place because this part is really more about, as long as we have accuracy to the point where we know where the geometries are and we know what volume this thing consumes, that's good enough. Of course, you can be extremely accurate with this and model it in full detail if you'd like to, but for the sake of today's exercise, to ensure we have a part that's ready to roll out, let me just show you how to do that. So what I'm going to do is use the move function one more time, and I'm going to click on this part, and I'm going to just check this mark here that says create copy. Now, do we have any dimensions telling us where these parts are? No, but we do know that this one's on the inside and that one's on the absolute limit there, and there's 4 of them in total. So what I'll do is, while I've got the create copy in place, just move it. I can reset my pivot point to make sure I've grabbed the right reference edge, which in this case is this one, and then grab it again and click on this surface. Now I'm going to hit OK here. This is starting to look a little messy, but it'll make sense in just a second. If I hit Q on the keyboard, which is the shortcut for press pull, I can select that inner surface and just pull it out like that. This is really more just for making it look a little bit more realistic. And when I hit OK, it's rebuilt that surface with the new ring. Now I'm going to use that same repetition that I used earlier on, the rectangular pattern, and the distance type I want to use is extent, which is great. This is the thing I want to move. This is the direction I want to move it in, and I'm going to pull it that way. Now, I know from earlier on that my absolute limit here is 20.61. But I haven't factored in the actual thickness of my part. So again, it's going to be 20.61 minus the 1.2 millimeter, sorry, plus, excuse me, I've forgotten my positives and negatives there. And now you can see it's coincident with that face. Now I've only got 3 repetitions here, but I need 4. And the next thing I need to do is just make sure that this is all one geometry. Looking at our bodies folder over here, you can see this is a ton of parts. So I'm just going to hit combine. It's going to ask me for the target body and the tool bodies. Now, when you're using the join operation, all this really denotes is what is the root file going to be. In my case, I want the root file to be body 1, and then my targets and my tools will be these pieces. As soon as I hit OK, you'll notice over here that we've had a bit of consolidation of the number of bodies we have, and body 1 is now that whole piece. So we're nearly done at this stage, and the last part to do is put the connectors in place. So with the connectors, we know a little bit about them. You know, our connectors are 4 millimeters away from this distance, and there's 16.7 millimeters between them. Beyond that, we don't actually know much more about them, but we do know that these are standard parts. So we know what those connectors need to look like. Now, I have to put my hands up and admit that I'm not the best at electronics. It's not my background. So I'm going to draw these in place, but you as the electronics experts will know what these connector dimensions need to be exactly. So please don't judge me too harshly if I put this in place and you notice that the connector dimensions are completely wrong. What's more important is to ensure that we give you a takeaway on how to model these things and get them done quickly. So what I've done is I've clicked on this surface to create a sketch again. I know that I've got a 4 millimeter offset from this side for my first one. So what I'm going to do is go to create. I'm going to use the offset tool. Now you can see me wandering back and forth with my mouse like that. And it's actually because modify lives here. But I'm also a little bit dyslexic, so I struggle looking at menus. So what I like to do is hit S on the keyboard, which brings up the sketch shortcuts. And this brings up shortcuts anywhere, and I can just start to type offset, and it'll find me all the tools that have O and F in them. That's the one I want, so I'll click on it. That's a neat little shortcut to know for when you're trying to find tools, like someone tells you that, oh, it's this tool, but you don't know where that tool lives. You can just hit S on the keyboard, and it'll help you find it that way. Now, one of the things that's important to note before I click on anything is I want to switch chain selection off. If I have chain selection on, you can see as I hover over one edge, it's highlighted all of them because they're connected in a chain. I don't want that. I just want to use one as a reference. So I'm going to grab that and I'm going to pull it this way and tell it it's -4. And I know that that's where the starting point of this piece is. You can probably guess what I'm about to do next. So I'm going to draw a little rectangle. Excuse me, I hit the wrong thing on the keyboard there. I'm going to hit R on my keyboard to draw a little rectangle, and I'm just going to kind of eyeball this for today and call that 3.5 by 1.8. And then to give some realism to the model, I'm going to use a slot function here, and I'm going to use our center point slot. This is going to help me mimic this geometry, so it's going to look a lot like this shape. So we're going to click here. I'm going to pull my mouse down. That looks to be about 3 millimeters down on the sketch, so that looks correct to me. And let's set this to 0.7, or that looks too skinny, 0.9. Cool. And just to make life a little bit easier later on for when I actually do the extrusion, I'm going to hit T on the keyboard, which brings up the trim function. Now with the trim function, I can just go ahead and, don't want to do that, excuse me. I can go ahead and get rid of some of these pieces. Now, what this does is, you may have noticed earlier on when I was doing extrude, it denoted, Fusion detected where lines crossed one another, and it broke out the extrusion into separate profiles. You can see here the same thing is happening. These are separately selectable elements. And that's because we have a long line here. If I delete that line, you can see now we have just a single piece. And that's what we want. So we'll finish the sketch, we'll hit E on the keyboard, and these don't sit on the outside based on this drawing. They're flush with the surface. Actually, they're inset a little bit, you can see there. For the sake of today's exercise, I'm not going to inset them, but I will push them inwards because I want to show you this function and also just to help you get the geometry ready. So if I pull this inwards so that it collides with the geometry, again, Fusion automatically detects that, and it's asking me, do I want to cut? Now, strictly speaking, I do want to cut because I will eventually do that. But in this case, what I'm going to do is set it to new body and set this to -0.5 and go ahead and hit OK. What I'll do next is pattern this across. Now, I can pattern it or I can mirror it. In this case, I'm going to use mirror because I'd like to show you how that function works. Under construct, there's an option here called midplane. Now, with midplane, what I can do is click here and click here, and I have a construction plane at the middle of my geometry. If I hit enter and then right click and go, excuse me, not right click. If I now go to create and then mirror, I can then go to bodies, select my object and use this as a reference for my mirror. and go ahead and hit OK. I can do the same thing on the other side by going to construct and midplane and going 1 and then 2 and then going to mirror again and selecting these two pieces and mirroring it this way. But oh no, I need to do my cuts. Now, if I go to modify and combine, I can say cut. Now, under the cut, this is what I want to cut away from. And these are the tools that I want to use. And you'll see that it highlights them in red, telling you where the cut's going to happen. Now, something that's important to note is there's a check mark here called Keep Tools. So as a way, again, of helping you expedite workflows and keep things neat and clean, Fusion enables you to basically use geometries as a reference to cut away from other geometry and then automatically remove the tools that you use to make the cuts as part of the same operation. Now, in our case, we definitely don't want to do that. We want to keep those parts because they're our connectors. So we'll activate Keep Tools, go ahead and hit OK, and there we go. We're basically ready. This gives us all the geometric data we want. And we can use this as is on our PCB, or continue to work on it and edit it and give it more detail. So for example, I can go to modify and then chamfer and grab this edge and start to just bring in a little bit more detail on the thing. So that looks like a 1 millimeter. And then if I right click and repeat the chamfer and pick all these edges, I can do the same thing and so on and so forth. So basically I can just keep rolling with this and add as much detail as I want or leave it as simple as I want. And I can even go ahead and put a little bit of material on this. So let's go to brass. I know there would be gold connectors, but brass will do. And there we go. And now we have a part that's ready to roll over to Fusion Electronics.
Yeah. Could you use the final stage as of exporting it maybe to a step file?
Of course. So as our final step to export that to a step file, couldn't be easier. We go File, Export. Got to make sure that we pay attention here. So it's going to ask you what file type you want. You'll notice that there is a squillion different options available to you, but of course we just want to use step. So we'll go ahead and click on step. It's going to ask you where you want to put it. In my case, I'm just going to leave it in my downloads folder, and we'll call this our quarter jack. Hit export, and you'll notice that Fusion actually will tell you when a part is ready to be exported if it's going to take a while. In our case, because this is a very basic part, if I go over to my downloads folder, and we go date added. Did I put it in the wrong place? My apologies.
It's all good.
I mean, the most important thing is to know that by going to File, Export, and then hitting Step.
And then it's finding the correct. Yeah, it's under your downloads folder right now.
Let's be lazy and chuck it on the desktop.
Okay, there you go.
All right, there we go.
Excellent, Paul. Thank you so much.
You are very welcome. Yeah, I haven't cleaned my desktop in a while, but it is in there.
Excellent. Well, thank you everybody for joining us, and thank you, Paul, for sharing your knowledge and putting this together so fast for us. That way, those of us that are kind of new to Fusion 360 have somewhat of an idea of what's going on and how to use it. It is a little bit. I'll be honest with you. It's really straightforward how to use Fusion 360. There's a plenty of resources on the YouTube channel of Fusion 360, how they even get started. But I think today, with Paul's indications, you would be able to actually, draw the appropriate shapes that you need. Do the Just go ahead and create the extrusions that are necessary. That way, you could actually build your own component and export your step file. Remember that you could upload that step file to library.io. That way, it's available to you when you want to add the component when you're in the managed library, or you could just upload it directly when you're in the package editor in the library editor, or you could actually do it from the schematic directly if you're editing the package directly from the schematic. Paul, thank you so much for all the information It's been awesome. Also, if you have some more questions about what we presented today, make sure that you visit the Autodesk Eagle forum page. So you just look up Autodesk Eagle forum, and Jorge and Richard. I try to be as active as possible there as well. If you have any questions regarding today, Paul,